Hello one and all, it's time to share the last video on complex number or imaginary number. Although these portions have been deleted from the syllabus of class 11 this year due to corona. So now still I have to teach you through the video. So let us see Cartesian form of complex number. This is called Z is equal to A plus IB. A plus IB stands for AB. If AB stands for A plus IB, then this length is called A and this length is called B. The real part will shifted to the bottom, the imaginary part will shifted to this length along the vertical. Now the polar form is Z is equal to R cos theta plus I sin theta. What is polar form? You know the meaning of AB, A and B. Likewise the meaning of R theta. This is the polar representation. R means this length is R and this theta is this theta, and the R is well known to you. The value of R is equal to A square plus B square by Pythagoras theorem. This is A square plus B square. Now take sin theta. Sin theta is equal to B by R. So B is equal to R sin theta. Similarly A is equal to R cos theta. Now we know that Z is equal to A plus IB. So this is R cos theta plus IR sin theta. Take R common, then Z is equal to R cos theta plus IR sin theta. This is the polar form where R is equal to root over A square plus B square, and theta is called argument or amplitude of the complex number. Now how we find theta? This is more important. To find theta in first quadrant, we get alpha first. Tan alpha is equal to B by A. For the moment let theta becomes alpha. So then if theta becomes alpha, because this is the first quadrant where theta is equal to alpha. So if theta is equal to alpha, then tan alpha is equal to B by A. Tan alpha B by A, perpendicular by base. So use this to find alpha. After that follow this instruction to find the amplitude or argument. This is called theta. Now theta is equal to alpha in first quadrant, theta is equal to pi minus alpha in second quadrant, theta is equal to alpha minus pi in third quadrant, and theta is equal to minus alpha in fourth quadrant. Sign is changed. The sign of this is changed, so it is easy to remember. Now first question, convert this to polar form. We know that 3 plus root 3i is 3 root 3. This is the first quadrant where theta is equal to alpha. Now get R is equal to A square plus B square. R is equal to A square plus B square. So we got R is equal to 2 root 3. And tan alpha by this formula, this gives alpha is equal to pi by 6. Now the required polar form is Z is equal to R cos theta plus I sin theta. So put the value R and theta, we get the required polar form. Similarly, to express this to polar form, 1 plus I root 3 is available in denominator, so it must be replaced, must be rationalized. So on rationalizing we get this. You know how to rationalize from previous video. So this means minus 4 root 3. This is the second quadrant. In second quadrant you follow this scheme to find theta. Just see, theta is equal to pi minus alpha. Now first of all we find R is equal to A square plus B square. So this is 8, and tan alpha is equal to B by 8. So this is 4 cancelled. So this is root 3. Root 3 is equal to, so alpha is equal to, sorry student, this is root 3. On cancellation this is root 3. So alpha is equal to pi by 3, 60 degree. Now polar form is Z is equal to R cos theta plus I sin theta. Now put the value and get the answer. This is all about the Cartesian and polar form of complex number. Now moving towards complex numbers. Now the second item is solve the complex equation. Solving complex numbers equation. So complex number equation, how to solve this? Let us take the first example. Do by quadratic formula. complex quadratic equation. It is called complex quadratic equation. And how it is solved? 2 by quadratic formula you know, for x square plus bx plus c is equal to 0, x is equal to minus b plus minus root b square minus 4ac by 2a. Use this to solve all the complex quadratic equation. Let us take one example. For number root 3x square minus root 2x plus 3 root 3 is equal to 0. Now simply set in this. So x is equal to minus b. So this is root 2 plus minus b square root 2 square minus 4 into a into b, 3 root 3 by 2 root 3. So set in this formula and get the answer. 2 plus minus, this is 4 minus 3 3 are 9, 9 4 are 36. So we are getting, this is 2 simply, students. This is 2 root 3. So this is root 2 plus minus 34 by 2 root 3. And earlier I taught you that due to I square is equal to minus 1, this can be written as root 2 plus minus 34 I square by 2 root 3. So this is root 2 plus minus I root 34 by 2 root 3. Root 2 plus minus I root 34 by 2 root 3. This is your final answer. So it is very easy to solve. Sir, please so this is your very easy to solve the complex quadratic equation. No need to discuss unnecessary once more. Now to find the square root of complex number. Of complex number, generally to find the square root of a plus ib, let this becomes x plus iy. So for plus, the instruction is plus, and to find the square root of 1 minus ib, let x is equal to let this is equal to x minus iy. So for minus we use minus and for plus we use plus, but this can be exchanged, may be exchanged, no harm. Now let us find one of the square root to find this. Let us take one example. Root over this is minus 5 plus 12i. Now let it be plus. So let it be x plus iy. Now squaring both sides, we get minus 5 plus 12i is equal to x square plus 2xy plus I square y square. So this is equal to minus 5 implies minus 5 plus 12y x square, and due to I square minus 1, this becomes minus y square plus 2xy. Now equate real and imaginary part, we get equate real imaginary part, real imaginary parts, we get this is the real part minus 5, so x square minus y square is equal to minus 5 first, and 2xy is equal to, this is I also a student, I is missing, 2ab, 2xyi, so this is 2xy is equal to 12, 2xy is equal to 12. No need to simplify this. Now there is a formula to find x square plus y square equal to root over this square plus this square. This is ready-made formula. So x square minus y square whole square plus 2xy whole square. Now put the values from here. Minus 5 whole square 25, and this is 144. This is 13. After getting the third equation, we solve first and third. Solving 1 and 3, solve 1, 3. So 3 is x square plus y square, 13, and x square minus y square is equal to minus 5. This is cancelled, and 13 minus 5, this is 8. And 2x square is equal to 8. So x square is equal to 4, and hence x is equal to plus minus 2. So we are getting x is equal to plus minus 2 from second equation. From second, 2xy is equal to 12. So 2 cancelled, and x is already available. So y is equal to 6 by plus minus 2. So this is plus minus 3. X, y are ready. Now we noted also, since 2xy is equal to 12, so xy is equal to 6. Now this is possible if and only if is true. If x, y both positive or both negative, and hence our answer is root over minus 5 plus 12 by, we have considered x plus iy. X plus iy we have considered the square root of this. So put the value of x, both plus or both minus, plus 2 plus 3, 2 plus 3i, or minus 2 minus 3i. In this way we can find the square root of complex numbers. And the last topic is cube root of unity. This has been deleted also. So find the cube roots of unity. Cube roots of unity. So this is third root of 1. So let third root of 1 is equal to x. So this implies 1 to the power 1 by 3 is equal to x. So x cube minus 1 is equal to 0. Cubing this. Or you can write 1 is equal to x cube. So x cube minus 1 is equal to 0. Now a cube minus b cube formula gives us x minus 1 into x square plus x plus 1 is equal to 0. So we are getting x is equal to 1, and at the same time by quadratic formula minus b plus minus root b square minus 4 into 1 by 2 for this. And when this is simplified, minus 1 plus minus, this is minus 3. So this is called root 3i by 2. Now the cube roots of unity are, cube roots of unity are 1 minus 1 plus root 3i by 2 and minus 1 minus root 3i by 2. So these are the cube roots of unity. This is also called 1 omega square. And now there are some properties of omega square and 1. So just see the property which will be helpful to you. Properties. First property, 1 plus omega square is equal to 0. This will help you in doing the problem. When all are added we get 0. No need to be verified. You can verify at your own. This is called omega. This is called omega square. And from this we can use 1 plus omega minus omega square. 1 plus omega square is equal to minus omega, and omega plus omega square is equal to minus 1. You can use this. The second property is omega cube is equal to 1. When we multiply both, we get omega cube and the result will be 1. You can see at your own. You can verify this. So these are the properties which will help you and help you to answer the questions of complex number. This is the last video. Thank you very much, students. Thank you.